Okay, so I'm Jacob Trent, and my problem was BC 2005, number 4. So for part A, the question says, on the axis provided, sketch a slope field for the given differential equation at the 12 points indicated, and sketch the solution curve that passes through the point 0, 1. So here, this part has to do with slope fields, and they give you the slope equation, which is 2x minus y. So right here, I just set up a chart with the x and y coordinates for the 12 points, and I plugged the numbers into the equation and wrote them down here. And then down here, I graphed my slopes. So at each point, it has the little line for each slope. And then when it says to draw the curve, I drew it based on the slopes of the points. And that's pretty much it for part A. Okay, so the way they scored part A was you got 1 point for the 0 slopes, 1 point for the non-zero slopes, and 1 point for the curve. Alright, so for part B, the question says, the solution curve that passes through the point 0, 1 has a local minimum at x equals ln of 3 halves. What is the y coordinate of this local minimum? So a local minimum is when the slope equals 0. So for this, you would set the dy dx equation equal to 0, like this right here. So 0 equals 2x minus y, and then you would get 2x equals y. So the x coordinate is ln of 3 halves, so you plug ln of 3 halves into x, and then you get the y coordinate to be 2 ln of 3 halves. So the way they scored this one was you got 1 point for setting dy dx equal to 0, and you got 1 point for the answer. Okay, for part C, the question says, let y equals f of x be the particular solution to the given differential equation with the initial condition f of 0 equals 1. Use Euler's method starting at x equals 0 with 2 steps of equal size to approximate f of negative 0.4. Show the work that leads to your answer. So for part C, the skill being used is Euler's method. So it gives you the initial point, which is 0, 1, and you have to get to find f of a negative 0.4. So to do that, it says use 2 equal step sizes, so each step size would be negative 0.2. So to find f of negative 0.2, you have to do f of 0 plus f prime of 0 times the step size, which is negative 0.2. So f prime of 0, you go back to dy dx equation, which is 2x minus y, and the point is 0, 1, so you plug that in, and f prime of 0 is negative 1. So f of negative 0.2 is 1 plus negative 1 times negative 0.2, which is 1.2. So there you find out f of negative 0.2 equals 1.2. So now you have to go down to find f of negative 0.4. So f of negative 0.4 is f of negative 0.2 plus f prime of negative 0.2 and times negative 0.2. So to find f prime of negative 0.2, you go back to the dy dx equation, plug in your x and y coordinates, and you get a slope of negative 1.6. So f of negative 0.4 equals 1.2 plus negative 1.6 times negative 0.2, which is 1.52. So f of negative 0.4 equals 1.52. Alright, so the way they scored part C was you got 1 point for using Euler's method with 2 steps, and you got 1 point for the Euler approximation of f of negative 0.4. Okay, so part D says, find the derivative of dy dx in terms of x and y. Determine whether the approximation found in part C is less than or greater than f of negative 0.4. Explain your reasoning. Okay, so the skills used in part D is knowing how to take basically a derivative and concavity. So you have dy dx, which is 2x minus y, and you have to find the second derivative, which is the derivative of 2x is 2, minus the derivative of y is 2 minus dy dx, which is 2 minus 2x plus y. So the second derivative is concave up in quadrant 2 because all the points in quadrant 2 are the x coordinates are less than 0 and the y coordinates are greater than 0. And the concavity is positive and concave up. So 1.52 is an under approximation of f of negative 0.4 since all solution curves in quadrant 2 are concave. Alright, so the way this scored part D was you got 1 point for finding the second derivative and 1 point for the answer with reason.